Hello everyone, myself Kalai will be working as an assistant professor in the Department of Mechatronics Engineering, SNS College of Technology for past 10 years. Today we are going to discuss an important concept, heating and cooling curves. So which is very important and very much relevant to electrical drives and control, especially in motor thermal management. Okay. So before entering into the curves, let us quickly recall the fundamentals of heat transfer. There are three modes of heat transfers are there. First one is conduction, that is heat transfers through solid materials. Second one is convection, so heat transfer through fluid movement. And then third one is radiation, that is nothing but heat transfer through electromagnetic waves. So always we have to remember that heat flows from higher temperature to lower temperature. So understanding this principle is very important when analyzing motor heating and cooling behavior. And first we empathize, um, we have to understand thermal measurement needs. So identify the temperature sensor requirements, decide required accuracy. Next, we have to define what is the overheating problem and where do temperature fluctuation occur and what is the safe operating temperature. And then comes into ideate and then prototype. So generate cooling and insulation solution is a ideate one. For the prototype, build and test heating or cooling setups. This structured thinking helps us design better thermal systems in electrical drive. Now let us understand the heating curve. This we having the heating curve concepts. A heating curve is a temperature versus time graph. So there are two important regions. One is slope region, another one is flat region. So this slope region temperature increases. So heat energy increases the temperature. So in this flat or palette region, temperature remains constant. Why it is happen? Because the energy is used for phase change, not for increasing the temperature. For example, we take as solid to liquid, that is in a melting, and liquid to gas is a boiling. So during these plates, energy is absorbed as latent heat. So next one is a cooling curve concept. So now let us see the cooling curve uh, in the mapping concept. Here again it is a temperature versus time graph, but temperature decreases. So slope region temperature reduces gradually, flat region phase change occurs. So here gas to liquid, that is in a condensation, and liquid to solid is a freezing mode. And during this cooling palace, energy is released but temperature remains constant. So this released energy is also called as latent heat. So here this is the cooling, this is the heating curve based on our explanation, and these are all the cooling curve when high temperature to low temperature. And this is a phase change and latent heat. So let us clearly understand this. Here melting is a solid to liquid, that is absorbs latent heat of fusion. And freezing is nothing but liquid to solid, which releases the latent heat of fusion. Third one is vaporization. Here liquid to gas, that's it, absorbs the latent heat of vaporization. And and another one is condensation, that is has gas to liquid, so it is nothing but releases the latent heat. And final one is deposition. Here direct solid into gas. So the key idea of this is during phase change temperature remain constant and energy exchange happens without temperature variation. So this concept is extremely important in thermal system design. Now let us connect this to electrical drive. So in motors, heating curve due to that is I square R losses, mean core losses, friction losses. If heat is not removed properly, insulation damage occurs. So efficiency reduces, motor life decreases. So and then cooling method includes the air cooling, liquid cooling and heat sinks. Temperature monitoring uses comes under the thermal sensor, protection circuits, overload protection systems. So here heating and cooling curves helps engineers to predict the motor temperature rise and design cooling systems with improvement of efficiency and ensure the safety. So this is about the motor thermal management of by the use of electrical drive. So here the test phase. In this test phase of we perform performance testing, efficiency testing, and temperature profiling calorimeter based on the results. So we refine and optimize the design. So this iterative improvement ensures reliability and energy efficiency. So finally we conclude. So let us summarize the heating and cooling curves or temperature versus time graphs. Sloped region indicates the temperature change and flat region indicates the phase change, and latent heat plays a major role. These concepts are vital in motor thermal management uh, by using the electrical drive. So the final takeaway is understanding the thermal curves helps in designing safe and efficient electrical drive system. Thank you.